Starting out things with the jet stream. Here are the jet streams on planet Earth, the Western world, and look at the chaotic jet stream flow here. We got areas of the jet stream blowing due north and due south. It's like a textbook definition here of meridional jet stream flow. The jet stream splits into two here just off the east coast of the U.S., blowing cold air down toward the equator, making for a cold day in eastern Cuba, for example. Here are the surface winds of the Western world. Powerful low off the southeastern coast of South America. Here are the surface winds of the eastern world. And here are the jet streams. It's 250 hectopascals. If you're wondering, we are on nullschool.net. I would once again remind you to follow us on Instagram. And I wanted to just take a moment during this meteorology segment to show you a perfect example of a frontal boundary. If you think that's a chemtrail or even a contrail, well, you're an idiot. That is a frontal boundary. As we had a warm front moving into Pennsylvania yesterday, and I got a fantastic view of this. I included some choice photos of the frontal boundary. This is north of the Blue Mountain here. This one here is near... This is on Route I-76, the northeast extension, the Pennsylvania Turnpike. And a great example here of a frontal boundary. You can see a different pressure regime. So what we're talking about here is a different pressure and a different temperature on either side of that cloud, those stratus clouds. Those are probably at an altitude of about 3,000 to 5,000 feet. They're pretty low clouds there. And you can see this clear sky. That is the warm front moving in. Perfect example of a frontal boundary. Not quite what we would call a squall line. And yes, I'm a true weather nerd. Next, looking at lightningmaps.org, and we actually see some significant terrestrial lightning here striking in Texas and Oklahoma. Shout out to our Texas and Oklahoman viewers. If you're in Oklahoma City, go out and look to your southeast. There's quite a light show down there. And you're actually looking at the propagation of thunder. It's lightningmaps.org. It's where I go when I hear thunder. It could save your you-know-what and prevent you from doing something stupid and going right outside to where there's a massive thunderstorm happening. Significant thunderstorms that are happening. So here's the NASA GOES lightning mapper. And I think we're looking at about 6 hours here. From 3:30 to 9:25. So 6 hours of data there. The NASA GOES lightning mapper. And I included the scale down here to show you the scale is indicating number of flashes per 5 minutes. Next, we're looking at pressure on windy.com. They've got a great mobile app, by the way. We're not paid to say that. I just use it. But in any case, there is the GFS forecast for pressure at 12 noon tomorrow. And if you're wondering where we're located, folks, we are located here in eastern Pennsylvania, Lehigh Valley /PA/US. Right about here. Here's a U.S. Doppler radar map, and you can see that long string of storms from central Texas stretching up to the Missouri-Arkansas border. Also some strong storms in Nebraska and over Lake Michigan. Some snow falling in northern Colorado, as well as some snow showers happening in places like New Mexico, Arizona, and Utah, as it's April 28th and the snow continues to fall. Will it be a year without a summer? Leave us a comment. Let us know your theories. Let us know your theories about the way one large volcanic eruption could reduce the population of the planet by massive quantities. Anyway, here's what's going on in the cloud layer. And here's the water vapor map in case that wasn't enough information. And you can see massive pressure gradients being created in here, as dry air, folks, is more massive than moist air. So this air right here, much more massive than this moist air, and those massive pressure gradients have a tendency to produce violent weather. And you can expect these systems to move rather slowly here. As you can see, this dry air is not moving particularly quickly. The jet stream isn't really playing much of a role with this, and that is why these systems are going to stagnate a little bit. And that's today's meteorology segment. We'll have to say goodbye to Twitch once again. Bye, Twitch.